Now let us see the chemical properties of the group 13 elements. And in the first in the list is the reactivity towards air. See, the crystalline boron doesn't react with oxygen at all. It is the amorphous boron and the metal aluminium, they react with oxygen on heating, leading to the formation of the oxides. The reaction is almost as like this. Boron reacts with oxygen only on heating, then it forms B2O3. In a very similar way, aluminium reacts with oxygen and it forms Al2O3. So we can make it twice. This will become thrice and 4. So this is how they react, and they all form the oxides with the general formula. The general formula is M2O3. Now what we find is that these oxides like boron oxide, aluminium oxide, gallium oxide, indium oxide and thallium oxide. The boron oxide is acidic in nature. It combines with the other metal oxides which are basic and forms the metaborates, the salts. The aluminium oxide and gallium oxides, they are found to be amphoteric in nature because they both react with acids as well as alkalis, whereas indium and thallium oxides are found to be basic in nature. So this is how what we are having their properties. Another important thing is this, that boron and aluminium, specifically aluminium, when heated with air or in air with oxygen, they also combines with nitrogen and they form the corresponding nitride also in small amount. So these are the reactivity in air. Now let us see their reactivity towards acids and alkalis. See, boron doesn't react with acids and alkalis even on or at moderate temperatures. It is the aluminium which reacts with both acids and alkalis, and that's why it shows amphoteric behavior. When treated with hydrochloric acid, aluminium gets oxidized to Al3 plus, forms chloride and leads to the formation of hydrogen gas. So we can write it, it will be 3, it will be 6, 6, it's like this. So what we find is, we can make it twice, so that it becomes balanced. So what we find is that aluminium reacts with acids, dilute acids, and leads to the formation of hydrogen gas. Remember, it is the nitric acid with which aluminium forms a protective layer of its oxide, a very thin layer of its oxide on its surface, which prevents its further exposure to the acids, and that is why its corrosion is prevented. Another important thing is that this sodium also reacts with dilute alkalis, like it reacts with NaOH, and leads to the formation of this complex sodium tetrahydroxido aluminium aluminate, and along with the release of hydrogen gas. So these reactions shows that yes it is, since it is reacting with HCl as well as with NaOH, it shows amphoteric behavior. Now let us see the third property, the reaction towards halogens. The reaction towards halogens. Now they all react with halogens on heating and results in the formation of the corresponding halides with the general formula MX3. So they all form trihalides. I'm talking about except the last one, the thallium. The thallium prefers to form this one, doesn't form usually because thallium is more stable in +1 oxidation state, so it prefers to form the monohalides. Otherwise, they all react with halogens and forms the trihalides. So this is what we have their chemical properties.